All right, so I think I'll get started here now. So welcome to Lunch and Learned. My name is Paul Kovacs. I'm going to be doing this on the intro to Git, how to manage your code better. I'm with the Civil Engineering Department. I'm the computer analyst for the department. Just to give you a little heads up, this is going to be a very basic intro. This is for people who haven't used Git before. So if you've used Git in the past, this is pretty much going to be a refresher for you at best. I think that this talk will be divvied up into maybe an advanced and intermediate sections as well. But let's get right into it. So just as an overview, I'm going to talk to you a little bit about what Git is, just in general. I'm going to give you a few concepts and fundamentals of Git that will help you use Git effectively. I'll show you how you can get yourself set up with Git. I'll explore some of the operations. I'll tell you how to use some of the features with Git, which is basically undoing things and branching. There's lots more features, but we won't cover them here today because it's such a big, there's so much available within Git, so I'll cover as much as I can. So really, what is Git? So Git is a version control system that records changes to a directory or a folder over time. So if you've done any sort of development, you might end up with a folder that looks like this, where you've tried to track all of your changes. You have these different versions. You don't really know which file is which. You might have made some different adjustments. But really, you don't even know the logical flow of these files. Maybe the timestamp will help you, but still, like maybe you went back and did some development on some code at a different period of times, and your timestamps aren't really even a good direction of how your development has happened over time. So Git really helps solve this cumbersome way of tracking your development iterations. So if you can imagine that if you had a directory that looked like this, if you're using Git, you can basically have a directory that looks like this on the right, where you only have this one file, but you have some different versions associated with that file, where you can essentially make an initial analysis down here. You can tweak some of your parameters, which might give you your power spectrum analysis version 2 within the last slide. You can add in some other options, and you can see as your development goes forward, really your directory is the same, and you have these little notes for you along the way, so that way you can easily revert back to version 4. And you can tell yourself, okay, this is what I was doing. So just a little bit on the development of these version control systems. So basically, the leftmost is what we would call a local system. So that's basically what I just described, where you're storing all of these files locally on your computer. You're essentially maybe taking snapshots of a file, of a folder, and putting a timestamp on it, and then doing that as you go forward. So the problem with that is that, for one, you need to do manual backups. If you want to have any sort of backup at all, you have to do that yourself. You have to take your folder, copy it somewhere else, or you have to set up some sort of automatic backup system like that. The second is that it's really hard to collaborate. So if you wanted to work on a code base with someone else, you basically have to take all your code and give it to them. And then they can do some edits, but then when you come back, how are you going to merge these codes? Like, no one really knows what everyone's working on. Everything's so separate. It's really hard to collaborate. So the next step up is to basically have a central version control system, which hosts your control system here. So this is essentially a remote repository, so somewhere off that's not in your own PC, but somewhere that's hosted somewhere else, like some data center or something like that, which will host your versions. And from there, now, if you have two developers, they can each just go to this one site, wherever it's being hosted, and they can just check out the code themselves. So this kind of solves the collaboration problem, because people can check out different code and put it back into the same repository, and everyone can be aware of the changes that were made as they happen. But there's still a couple problems with this, and that's that if this server goes down, if this central server goes down, no one can check out any code, no one can commit any code, you're kind of stuck. The other thing is that if the server here becomes corrupt and you lose that data, then you're actually going to lose your whole version database. You might have whatever computer A has on his computer or computer B has on their computer, but you've lost all of the history there. So then we can move over to the distributed version. So that's essentially the same thing, where you have the central server, which hosts your database. But then when each developer or people on different computers are checking out their code, they're going to check out the entire Git history. And what that does is that enables backups automatically. So even if this server goes down and becomes corrupted and you lose all this data here, you know that you're going to have all of that data on computer A and computer B. So now you have pretty much as many backups as you have developers, plus one if you have it on a central server as well. The other advantage to this is that you can actually work offline because you have the whole history there. You can basically just do all of your work within your own system in your own repository here. And then once you're back online, you can push all of your results over to the central server computer. So just before I kind of jump into things, I just want to go through a bit of the nomenclature that you'll see flying around on here. So local is basically just the stuff that happens on your PC. That's the stuff on your actual PC here. A remote is basically a server that's going to host your data in a physically different location. So this might be some sort of data center. And for us, we will use GitLab to host our remote server in this example. A commit, that's basically one snapshot of your code. So if you've been doing some development and you wanted to take a snapshot in time of it all, that's what I would refer to a commit as. A branch is basically a series of all these commits. So you might see that you have a few different versions in a row, and that would be labeled one branch. And the branch, the commits need to follow one another, otherwise you start getting multiple branches, which we'll talk about near the end of this talk. So master, that's basically a default branch that, it's not default, but it's the typical name that you give to your first master branch when you're making these, when you're signing up for Git repo. That's just typically what people use. That can actually be anything. I'll use that in this talk. Origin, again, that's the typical name that is given to your remote repository. So the place that you're storing off in space, you need to give that a name, so that way Git knows when you say origin, it knows that you're talking about the remote repository. Finally is this concept of head. So this is kind of unique to Git, and it's essentially just a pointer of where if you're doing some work, where you're going to add that work to. So I'm just going to take a little bit of a second just to talk about the head for a second. So the head often points to the very tip of your version. So in the top example here, you can see version 1, 2, and 3. The head point to version 3, so that means that the next commit that you do, that will go on version 4, which will be referred to from version 3. Now that doesn't always have to be the case. Say you want to check out version 2 and you want to do some code there. You basically be pushing your head back to version 2, and then if you do a commit, it would actually, version 4 would follow from version 2. And so that chain would be version 1, 2, and 4. So that's just something to keep in mind as you move forward. So one of the things that will really help you understand as you move forward and start using Git are these 3 stages of Git. And so you can see this little diagram down here, which kind of gives you a bit of an idea of what's going on. So the first is modified files or your working directory. And so this is essentially stuff that you've pulled in one of these versions, and you have stuff on your PC. This would be your working directory. Now you can make edits to these files and anything like that. That's still considered your working directory. Once you have made some edits and you want to have your edits go into your next commit, so the next node or the next version that you want to make, you want to put those into a staging area. So you just take your files that you want and you can put them into a staging area. It's only those files that will get pushed over to the commit once you actually run a commit command. And then finally, you have the committed version itself. So that's essentially, so I have here, it says Git directory or the repository itself. This can also be referred to as the head, so it's basically wherever the head node is sitting. And then finally, a note to make is, as we mentioned, we have a local repository and a remote repository. So all this is going to happen within your local repository. So when you do a commit, you're just committing stuff within your own PC. In order for the remote repository to actually be aware of these changes, you just need to do a push command. And all that does is, so let's say if you were, you pulled out version 3 here, you did a few more updates, you made version 4, 5, and 6, and you push them back out, then this computer server here would contain versions 1, 2, 3, 4, 5, and 6. So to start up your first project, you can start it in multiple different ways. You can start by accessing files directly from a Git account on the web, which I'll show you really briefly. You can create a repo from existing computers or existing folder on your computer, which I will show today as well, or you can just create a repo from an existing repository that's already available on the web. So the first thing that you'll want to do is really get yourself up with a Git service. So this is where your remote repository will be hosted. There's tons of different services that do this. GitHub is probably the most known one. It's very highly used. GitLab is also a very well-known one. We'll look at GitLab in this project because I think as this series goes on, GitLab has a few extra features that GitHub doesn't. which we might be able to talk about in future talks. So I guess what we want to do is we just want to go and create a new project. So I've went and I've already signed up for a GitLab account. Here is what the new project page looks like. All you need to do is come here. You can click new project. It'll bring you to this page. And here all you have to do is give it a project name. So we have Git training. Oops. We have Git training here. And you can keep all the other defaults. That's going to be fine for just to start. And you say create project. So great, we have a project made, and this is the repository of the project. It says it's empty, and it gives you some tips on how you can make your project. As I mentioned, you can create a new repository, you can use an existing folder, or you can use an existing Git repository that's already there. So you can also just make edits directly on your remote server this way by essentially editing files here by clicking new file. If you want to add a new file, let's say if this was a test file, test file, and you can put some stuff here, and then you can actually just go and commit the changes, and so that will put this file directly onto your remote repository. Since I think many of you probably have some code that you're already have that you want to commit to a project, I'm going to show you how you can actually kick off your code from an already existing folder. So I'm basically going to follow what's here. So the only thing that's really going to differ is this. This is connecting to this remote repository through an SSH protocol. I'm going to make things a little bit. I just didn't want to go over that today, so I'm going to basically just use the HTTPS site instead. So that's going to be the only thing that it really differs from what I'll show you today. So in order to actually use Git on your computer, now that you have a remote repository set up for your Git, you want to be able to interact with Git itself and create these snapshots. To do that, you need a Git client. You can basically there's two ways that you can do this: through the command line or through a graphical user interface or a GUI. Pretty much anything that you can do within the graphical user interface, in the command line, you should be able to do in the graphical user interface. Now they're all going to vary in one way or another. I can't guarantee that all the operations will be there. Some of them are still being updated as we go along. That being said, I will go over some of the command line stuff today, because if you look online and you're looking for help on Git, you'll see a lot of help through the command line, because that's more universal. Everyone uses it. Pretty much anyone who's used Git has used the command line at one time or another. I will also, for a GUI, I will look at GitKraken, which is the one that I'm used to today. All right, so on top of that, so I'm just going to get us set up get my code set up onto this remote repository. So to start that, I'm essentially just going to follow these things here. So can everyone see that? So basically, the first thing it's telling me is to just change my directory to a different folder. Oh, sorry, I wanted to mention it also. So once you go here, this will download the Git command line. You can download it for all operating systems. I'm pretty sure that Linux and Mac OS come with Git installed, but you can get it here. So I've already done that, and as you can see on my command line, you can check if you have it just by typing Git. If it doesn't complain that that's not a command, and you get some other info about it, then you have it installed on your computer. So to get us set up, I'm just going to follow these steps. And so it just says to change directory to the existing folder that you want to commit. So I will just go there. So if you look, I have this repo here, which I've set up for this. And in here, there's one Python file, which I wanted to commit. So now we just can continue what it says here. So we'll do git init, and so all this does is basically initializes a Git repository. If you see, it'll add this .git folder here. So if we go to the folder and go into the repo, you can see it added this .git, and so this is where Git will hold all of its stuff. So the next thing to do is basically to tell Git where our remote repository is. So we're just going to do git remote, and then add, and then we're going to give it a name. And as I said, typically you want to give it the origin name. And here, again, as I mentioned, this is the SSH protocol, but I'm just going to use the HTTPS, so I can just give it here. Okay, so now I have told my repo where my local repo where my remote repository is. So if I do git add, and I'll go over a few of these commands. So this is basically just adding everything in this folder to the staging area, and I can commit those changes over within my local repo. So git commit, and I'm just following what's here to get us going. And initial. Okay, so you can, now it tells you that you've made one change, there's 2 insertions, gives you some info about your commit. So finally, like I said, this is all happening on your own PC locally, so to get it over to our actual folder, so here it still thinks that there's nothing available, so if we refresh the page, it still says your Git repository is empty. So all we need to do is push those changes. And so we can just do git q, and then origin to tell it which one, and the master, which is the branch that we want to push to on the remote server. So once we do that, sorry, I don't need this. Oh, I missed push. And so this is going to basically push all the stuff that we have in our repo over to our remote repository. So now if I refresh the page, we should see that, yes, indeed, we can see the Python file that I put there. It has one operation in it. So now we're good to go. We have our remote repository set up. We've linked it to our local code base that we wanted to. We've initialized our local code base with the Git repository locally. So the last thing that we might want to do is essentially get it connected to one of our UIs. And so the UIs, you can start the Gits in much the same way that you can on the command line, which I just did. So since I've already initialized everything within command line, I will just do open a project. So here you can see that you can do an init here as well to start a new project. But since I've already set this one up, so we can just open it up, and you can see it already is aware that we have this one commit there. And so this is essentially what the UI looks like. There's lots of information just right at the head here. And I'll talk a little bit more as we go along through the talk. So one thing to note is that on top of the 3 stages of Git itself, so that's the 3 stages of the Git repository, your files can also be in 4 different stages or 4 different states. And the Git status will actually tell you about these states. And so here's a little diagram that kind of can help you remember what you need to do for each position. But basically on the left you have untracked files. Let's say if you have pulled in a Git repository or pulled in some commit, and you have all this code there, but you've added a new file. Now that's currently an untracked change. This Git doesn't actually know about the file. Like it sees it, but it won't like if you do a commit command or if you do a commit or you do a push, it won't go along with it because it knows that it's supposed to be untracked, and so it won't push it along. So in order to do that, you have to use the git add command, and that will immediately put an untracked file into a staging area. Next is unmodified. So that's basically stuff that you've pulled in from a Git repository, have not changed. It's sitting in your working directory, but nothing has changed. Modified is basically those files, but you've modified them, but at this point you haven't staged them. So if you want to do a commit, they won't actually go until you've staged them. So much like a modified and an untracked file can be treated in much the same way. In fact, in the way that they need to both be added into the staging area before they can go over to the commit. So you can see that from here, anything from the staging area will go back to the unmodified once you run a commit command. So there's another operation that's basically to just essentially clone a repo. So if there's a repo already up there that you want to contribute to, or some open source project, you can just say git clone, get the URL, and then you can also give it an optional folder name if you want to name it something different. And that's just one way that you can pull in a repo from anyone else very easily. So let's say you were in that situation. So here we see that I just pulled in this repo. We have this one file.txt. It's only version 1. And these are the 3 stages of Git. So my head is currently looking at this file. My index, which is also the staging area that can be used interchangeably, also is still looking at the same file, and the working area is still has not, there's been no adjustments made. So once you edit a file, you'll see that your working directory will actually change. And so here you can see that this file has technically, Git recognizes that this is in version 2 of this file. So it knows that it's been edited from version 1, and you're working on it within your working directory. Now, in order for you to actually get those commits into the next version or the next node, you'll have to use the git add command, and that will stage the file as it is at that point. So let's say you've done some work. You've done some work on a file. You're like, yep, this is what I want to commit. So all you do is you say git add, and then the file name, and that will put it into the staging area for you to commit. I'll go over all of this in the command line in just a second. Just one thing to note is that, so let's say if you so you made some edits, you stage the file, and because you're confident that's what you want to push on your next commit, but then you realize that there's a couple other edits that you want to do. So Git will actually retain both versions of that file, so whatever you've staged the first time, that's what's going to stay staged. If you want your new edits to go in there, you need to restage what you have. Otherwise, Git will just think that Git will use the file that you've staged in the first place. And then, so the last thing that you want to do is you want to commit. So you can see that that now our 3 states of Git down here at the bottom are all pointing at the version 2. And we've actually seen that we've created this new node which has our head and has the name master, or the branch name of it is master, pointing to this commit. And so then finally, as I mentioned before, that's all happening within your own PC. That's all on your local PC. That's all happening just on this hard drive. And if you're using a remote repository, you need to push those commands back out to the remote repository. So once you make all your changes, you might have a few nodes in there. You push it back out to the remote repository and everything, and it will be aware of everything. So let's go ahead and maybe do something along those lines. So let's say we are looking at our code base, and we realize that we really need some documentation. So right now there's no documentation in here, and so we want to add some. So your file should always have a header. So we've added some documentation here, and we can save the changes. But let's say on top of that, we also want to provide a README file. So we're going to add a new file, and let's say welcome to Git training. So I'm going to save that as a new file. I'm in my Git repo here, so this is, sorry it's so blurry, but I'm in my Git repo here, and I'm just going to save that as a README file. Okay, so at this point, I have made an edit to a file, and I've added a new file. So as I mentioned, the git status command will tell you the status of all your files. So right now, if I do git status, we're going to see that it's going to say there have been changes made to some files, but they're not staged for the commit yet. So it's saying, all that's telling me is that it knows I made these changes, but if you want to run a commit, nothing's going to commit there. Here, again, it tells me that this is an untracked file, so this is one that I've just added. But it's still in the untracked state. So in order to get those both into the staging area, I can just add them both. So you can use the git add command to do that. So you can do git and add, and then you just want to give it the file name. So let's start with adding the README or the operations. So once I do that, I can go back to git status. And we see here that now it's telling me changes to be committed. So on the next commit, whatever changes are made in this file will be committed. But still, the untracked files are still README is in an untracked file. So we can also add that by using git add and then just README. So one way that if you have multiple files like that, you can actually do git add and dot, which is what we did when we set up the repo, but git add dot, and that just adds all the files in that current directory. So now if we look at git status, we can see that now everything is ready to be committed. All of our changes are ready to be committed, so let's go ahead and do that. So we can do git commit, and so with every commit, you need to add a message, and this is basically a note for other developers, telling them what you've done on this commit. And so here we've added documentation. All right, so now it tells you that you've committed the changes. It tells you that 2 files changed. It gives you, again, gives you some info about what you've just done. So if we actually look at our UI, we can see that this change has happened here. And it's already aware of the second one, or the second commit that we've made, which is added documentation. So within the UI, you can see a lot of this information just right here. So here you can see, the message that came along with the commit. If you hover over here, it tells you who made the commit. Here are the files that were changed. So here you can see that the ones with this symbol are modified and ones with this one are added. You can see what was actually, if you click on the files, you can see what was actually added. So here it's showing you these 4 were added. They weren't in the previous version. But you can get a lot of info from that just by looking at the UI. Also, you can see here, so we have two indications to master. So we have a master branch both on our local PC and one on the remote repository. So one of these is the local PC, and that's what this is. So you can see if I hover it over there, you can't really see it. Sorry, that's very small. I didn't realize how small that would be. I wonder. Perfect. Oh, it doesn't let me zoom in anymore. So it's all this is telling me is that my local is pointing towards this commit, and my remote repository, which is this one, so I've given it the name origin, is actually pointing to the first commit. So what this is telling me is that my remote repository is actually one step behind of my local repository. So Git, within the command line, you can actually find this information as well. So using just the git log command, and so here you can see it just gives you some general info, everything that I've just mentioned. So you can see it tells you who's made the commit at what time, the message that was added, the message that was added on the commit, and then you can also see these long strings of characters. So this is basically a hashing of your code, and what all that really means is that this is an ID for your code. So anytime you make a change, this ID will change, and it's very unlikely that you're going to have two identical IDs that are conflicting. So you can consider these to be the IDs of the commit. So if you ever want to revert to a certain commit, you can always use this ID when you want to undo things, which we'll go through in a little bit. But the big thing is that that's essentially just an ID for a particular commit. So also what you can see here, as I mentioned before, so in this situation, when I made this, you can see that our local branch, which is in green here, the head and the master are both on this one commit, whereas the remote repository, the origin master and the origin head are both pointing at different commits. So again, in this situation, our remote repository is one step behind of our local repository. So in order to do that, all we need to do is do a push command. So if you come to your command line, you can say git and then push. And when you want to push something, you got to give it which remote you want to push to, because maybe you have more than one remote. So again, you just give it the name. We've given it the name origin, and then which branch you want to push to on the actual on the remote server. So we only have one, which is the master. So once we push it, it'll tell you, give you some information about the push. If any errors happen, it'll tell you here. But if we go to the UI, you can see that now our master and the origin reside are both pointing to the same node, and you can see that in git log as well. So now the head and the master and the origin are both pointing to the same spot. Okay, so now I just want to talk a little bit about actually undoing changes. So first I want to talk about, how much time are we at here? So first I want to talk about undoing changes that you haven't committed yet. So these are things that you've worked on, and you basically want to revert back to what where you were at in the first place. So let's say you're in this. So let's say your working scenario is like this, and you've checked out this version, you've made some edits to it, you've staged some of those edits, but then you realize like those aren't actually what I want to stage. that I need to bring those edits back, maybe do something else, or maybe I've just added the wrong file by accident. So to do that, you can just use the git reset command, and that will essentially reset, that will essentially unstage your files. So let's say if I go in here, and I added a new function, okay, so great, I've added a new function. So let's say I want to add those to the staging area, so if I do git status, it'll tell me that I've made, whoops. It'll tell me that I've made, I've made some changes, but they're not ready to commit yet, so let's add that file. And then we can see in git status, again, we can see that it's ready to commit. But again, let's say I didn't want to actually commit those, so I need to pull them out of there, so I can just use the git reset command and then give it a file name. So the operations that I want as file, or as operations. And so then you can see git status. It's, again, not in the staged area. And so this is actually really, really easy to do within the UI. You can see here, so for one, you can see it recognizes that we've made changes to the node that we're on. It's telling us, like, you've made some changes. Do you want to commit this node? It's a work in progress here. If I go, I can view the changes that are here, and it's telling me that this operations file. And so here, it's really easy. I can just tell it, stage this file and unstage this file. So the next level of that is, let's say you've checked out some code and you have some stuff in your working directory. You've taken Control-S along the way, so if your computer crashes, you don't lose it. But really, you want to revert to how that node was at the start, because let's say you've made a bunch of changes and you realize, like, this is not going how you planned, and you need to essentially restart, which happens to us all. And so in order to do that, you can essentially do the same thing. So let's say I have this one here, which I've done some changes to. I can use the git checkout and then give it a file name. So the git checkout, you need these double dashes because you can use the git checkout command to switch between branches. When you give it a double dash, that's to just tell the command that this is a file that we're looking for, because sometimes you might have a file with the same name as a branch. And so what that will do is, if your 3 states of Git look like this, where you have a working directory, it will just kill everything in your working directory. Now, one thing to really be aware of when you're doing this is that you will lose your changes here. So you have to be really careful. There's not many operations in Git that will destroy what you have. Most of it will always add more. But this is one of them. So you do have to be careful. So let's say I was in here, and I had my changes. So I have my changes there. But I realize, like, that is not at all what I wanted. I can use the checkout. Let's get this in the background. So I can use the checkout command. So I can do git checkout to tell it's a file, and then I can go operations. So once I do that, it will revert me back, and if I go here, you can see it just removed all the edits that I did. So you have to be really careful because you can lose your work. And so that's kind of how you might undo things that you haven't committed yet. But let's say you've committed something and you want to undo these changes. So that's essentially the situation where I mentioned before. You want to push back and look at changes on a different node. So what you want to do here is you basically want to use the reset command and give it a commit ID. So within the reset, there are 3 options: the soft, the mixed, and the hard. So I'm just going to run through those really quick, and then maybe I'll show you an example of them. Time dependent. So let's say you're working on this repository here. There's 3 commits, but you want to go back one and work on this one here because you realize this isn't quite what you wanted. What you want to do is so there's 3 versions of this, as I said: the soft, the mixed, and the hard. So the soft version of this, so let's say you say git reset, you tell it this commit, and then you say you tell it to do a soft. So what that will do is that will keep everything, all the changes that you've actually made to your code base. It will retain all those changes, both in your staging area and in your working directory, but will push the head back to where it is. So if you've done some edits so if you're working here and did some edits, and then you say git reset soft, it'll just push the head back to here. So if you have some edits that you made from here, which you actually want to add onto this node here, that's one way that you could do that. So the mix command is going one further, and that just resets your index. So it does keep all the changes in your working directory. So let's say if you have some edits there that you only want to commit one or two things that you've edited, then you can essentially do that. This is also a handy way of essentially squashing commits. So let's say if you made 3 or 4 commits at once, you can which might be better all in one commit. You can revert to the file that's furthest back. You can stage all of your edits, and then you can commit. And that will essentially squash your commits. I might get some time to show you that in a second. And then finally is the hard reset. Now this, again, is one of the destructive commands that you can do in Git, and you can lose all of your work really easily. Because as you can see here, this is going to reset the head, your staging area, and your working directory to wherever you're telling it to go to. So anything that you've done on this node here, you'll lose if you use the hard commit. So let's say we've made some edits. So we can go in operations, and we can put back in some things. Let's just make a couple commits really quick. So we have one. As you can see, one of the reasons why I like this is because you can even do file editing in here. I'm not sure if they all have that ability. I suspect that they would, but you'd have to just play around with different UIs to see what you like the most. So I made an edit. I saved the file. It's telling me it's unstaged, so I'll stage it, and I'll added subtraction. Whoops. And then we can commit it, and it'll keep pushing it forward. So let's do another one real quick here. Call it product. And say we have that. Save that. You can add product. Stage it, and then we can commit it. So as you can see, it's aware that we've made it here. And also within the git log, if we look at git log, they're both aware of what they're doing. So it's not like if you do something in one, the other one's not going to be aware. They work interchangeably. So, so from here, if we wanted to revert back to, let's say how we added the product wasn't right, or something like that, and we wanted to revert back to how we were. So we can do what I mentioned. Lost my spot. You can do what I mentioned, where it's we can use the git reset and point to a commit. So this is where these different commits here can come in handy, or these different IDs. You can basically take an ID and tell it git reset, and then we're just going to do a soft. Whoops. And then we can give it our commit ID. Whoops. This one. Okay, so now if we look at our git log, we can see that before we had added product, but now we don't actually have that within our log because we moved everything back, and it's not actually aware. Now it just thinks that that's a work in progress again. But we still have our changes here. We still have it in the staged area. We can easily repush that back. Okay, it doesn't want to let me do it here. This happened to me yesterday when there we go. So we can say added product. We can also do this in the command line. So how can this be useful for actually squashing your commits? So let's say you have this one where you added subtraction and added product, but there's essentially just adding two functions. So if we wanted to, so if we look at the git log again, we can see that we're back to where we were. But let's say if we wanted to essentially squash what we had and we want to revert back to this state. So we can say, I'll just do it within the UI here. So here we can say git reset master to this commit. And I'm going to do a mixed, just to show you what it looks like when we do a mixed. And now you can see that we still have our changes in the operations file, but they're just in the unstaged area. So in order to get those back to the staged area, I can put them in. And on here, I can just say added operators or something like that. And so as you can see now, I've changed those two commits into one commit. Sometimes that's helpful for cleaning up your code. It's not a super important thing, but it can be useful. And so finally, I just want to show you how the hard works. So if we want to do the reset in hard, you'll see that instantly I'll just lose everything. And I've lost that commit. I've lost all my changes. It doesn't have anything in my working directory. If I go over to my file here, it's going to look just like it was before I added those edits in. So again, that's one of the things that you actually really want to be careful about. Okay, so now I just want to talk to you a little bit about branching. So branching is a really useful tool in Git in the fact that you can create these branches to do development completely separate of the main branch, which might have continual work. But let's say you want to be collaborating with other people, you don't want to interfere with their work, so you can create these branches. And it's a good idea to just start creating branches for features because that's what people do in the real world, and it's a good habit to get into. So basically, so here in this situation, this would be called the master branch. You might have these line of 3 commits, and your master branch it would just be this one here. You can actually create a branch from any commit within your history, so you can just change over to that commit, and then you can run this command git branch and then give it a name. So for this example here, let's say we've made another branch called B1. I would say on my master node there, I'm going to say git branch and branch name. And so that will start creating these branches. So I just want to run you through a little bit of just like a scenario of how you can use these branches and how it might work. So let's say you're essentially working on a website, has a few commits, there's some stuff there. But then, you want to add some new stuff to your website, maybe a new story or maybe like a new page or something like that, like contact us or something along those lines. So you can create a branch and you can start doing some work there. So now you can see that you've made you've done some work on this branch, and so this branch, this B1 branch, actually has this whole commit history up to C4, whereas the master branch here still only has commit history up to C3. But now let's say you actually notice that there is a problem in your main site, and a bug that needs to be fixed. So typically people would create what's called a hotfix branch, and that's basically just something that you create really. You usually create it off your master or your development nodes, and then you can make your edits to fix the bug, and then you can put it right directly into your master branch. So that's what this individual wanted to do. So what they did is they switched back to the master, and then they created a new branch based on this node. And so now you can see that we have another branch based on that was separate, or that started from the commit 3 there. So now let's say you fix the bug, and you make a commit, so another commit comes in. Now this hotfix branch it has this history where it's C1, C2, C3, and C5. C4 is not in its history. And then you can go back to continue to do development on your feature branch that you were working on. But then you notice, okay, I have these 3 branches. My master's behind the hotfix. Like, what's going on here? So what you want to do is you want to start merging your branches. So you can use the git merge command and then tell it a branch. So when you use the git command like this, you basically want to switch to the branch that you want to merge from, and then tell it which branch you want to merge to. So here we would switch to the head node and say git merge hotfix, and that would push our master branch up here. So if one thing you might notice is that the master branch is the hotfix branch is directly upstream of the master branch. So there's no intermediate commits that it doesn't know about. And so when you do that type of merge, that's what's called a fast forward. Again, there's no divergent history here, so it just simply tells Git just tells the master pointer, okay, you can point to where this hotfix is. At that point, you're free to once you've merged your branches, Git won't actually delete them for you. You're free to delete it if you want. You can also keep it there for historical sake, or maybe you're going to end up using it again. But you can delete it at that point. And to delete it, it's the same way as creating a branch. You just give it this -d modifier, and that will delete the branch. And so, but now you have this situation where, you've done some edits to this other branch, or to your feature branch, and you need to merge it in with the master. And so when you do that, there's this commit here that is not common to either of them. So it's in the feature branch that we have here, but it's not in the master branch that we started with. And so what we want to do is we want to do a merge. Now this is where it can kind of get a little bit more complicated, because let's say if you have a situation where you have two different developers, one working in the branch and one working on the master, where they've essentially edited the same file. Once you do that merge, you're gonna see a conflict happen in Git, and when you do that, it's basically up to the developer to decide which of these versions that we want. And I'll just show you that in a second. So I've already set up this because I knew I would be short on time at this point. So I've set up a branching example, which is exactly what we have. So here we have our hotfix branch. We have our master, which is behind, and we have this. So someone wanted to make a square function. So you can see this person, they made a commit, they made a square function where it's x times itself. But then we also have this. So what we want to do is we've done our hotfix. We want to pull our master back up to our hotfix. So how can we do that? So let me just go to the command line. I'll do one in the command line and one in the actual UI, just so you can see both. So first thing I want to do is go back to the repo, because this is a different spot than I had before. Okay. So now I can do git, checkout, and master. Oh. What did I do wrong here? Okay. Sorry. Okay, I'm just going to show you within the UI, but so let's say, just for time's sake here, so let's say this master branch, we want to pull it up to the hotfix, and again, because this is directly upstream, because it's directly upstream here, you'll have the option of essentially fast forwarding. So all you need to do to merge your branches in the UI is basically drag one on top of another. So now it gives you some options. It says fast forward to master, merge hotfix onto master, or rebase. As I said, because it's directly upstream, all we want to do is move the pointer, so we can just use the fast forward option. And then, so now we can actually just, to delete it, we can just right click on it and we can say delete the hotfix. It'll, cannot delete. Oh, I need to, I can't be on that branch, so I need to switch branches and then delete it. It'll ask me, because it's a destructive command, it'll verify that you actually want to do it. So now we just have essentially our one branch and our master here. But now what we want to do is we want to merge the square onto the master, and if we do that, now it tells us that we have a conflict, and then all we have to do is come into the conflict here, and then what we need to do is, so as we can see, each developer here, one on the left here, he's made the square with x to the exponent of 2, and the other one did x times itself. So let's say you have someone who's managing the code, and he says, this is what we want. We can put it into this is the set that we want because I've profiled them both. I know what one is faster or something like that. So this is what we want to take. But that doesn't have to be the case. You can actually take both of them. So here in the UI, you have the two examples, but you can put them both, and this is what your output will look like. We don't want to do that here, so all we need to do is we need to just mark what we want, and then we can save the changes. And we should be able to commit and merge. And so now you can see here that that this branch has been successfully merged to the master branch. And so those are the kinds of conflicts that you'll run into when you start merging feature branches and things like that. And you just have to be aware of what version you want to pull in. So there's just some takeaways from my talk. It's a version control system which will help you manage and track your code. It's really good for collaborating with others. The three things that you really need to know to be effective in Git is understanding those three states: the head state or the committed state, the staging area or the index, and the working directory. I've linked the cheat sheet here. Luckily, one of our viewers today has brought a cheat sheet with us, so you have an even better version of that. And that's everything for my chat today. Any questions? Yeah.
Do you happen to know how much storage is there on GitLab or GitHub free available?
I actually don't know that number, but I'm sure that you can just go on their site and find out. I don't know if anyone else here might actually know that. No? Yeah. Yep.
If you're merging two branches and in each commit you have many different files, then you have to go in the config, you have to select what you want to keep for each file until you can finally merge them, right?
Yeah. So you basically need to resolve all of those conflicts before you want to merge them. If there's still something that's marked as a conflict, Git won't let you merge them. So you'd have to go through each one. So really, you want to try and keep things as separate as you can. It's not always the case because sometimes you will have two people who need to edit one file, but hopefully their edits don't actually conflict with one another, and it's just going to be adding more things to the file. Mm-hmm.
What's the reason between using HTTPS versus SSH?
So SSH is just a more secure protocol. I don't know all the advantages or disadvantages of the other. The only reason why I went with this today is just because I didn't want to go over the SSH stuff. Just because the talk was already pushing it as is. I think if I had planned this a little bit different, I may have left the branching for a different version and added that in as well.
Okay, so it seems like that's the more recommended version?
Yeah, and that's why when you go on there, that's like the initial commands that it tells you to use. But I think that maybe in a future version of the talk, I will add that in because I do think it's important as well. Yeah.
If two people work in the same program but they're different files and then they only merge one document at a time, or can they merge the whole folder?
It'd be everything that's in that folder. So when you do a merge, it's like taking the whole snapshot and merging with another whole snapshot. So it's going to be everything that's in there.
And if they're working in different files?
If they're working in different files, there shouldn't be a conflict. They'll just both get added when you do the merge. That make sense? Yeah. Yeah.
Is there a way to figure out if the dependencies in one file have changed in such a way that the current file doesn't work? Is that something that's in Git, or is it?
So I think that's one of the more I believe, if I'm understanding correctly, that's what you can use continuous integration for. So that's saying, I have this stuff that I want to merge, and you put it in. What you have to do is you actually have to have some tests up and running. So within your code base already, so that way when a commit does happen, you can set up this continuous integration, which I probably will talk about. I don't know if it would be in a Git talk or if it would be in maybe one specific to GitLab, but sorry, what was your question again?
So if there's, let's say
Yeah, and that's the whole point of having these test functions. So that way, you might have your master branch here, which has tests, like solid tests built in it, and then this other developer will be working on one of those branches. He's going to try and merge in, but when he merges in, the continuous integration feature will essentially kick off those tests, and if those tests don't pass, then it'll tell you like there's an error here. You shouldn't merge this.
What are like the general differences between GitHub and GitLab?
To my understanding, that they are very similar. I just know that GitLab does have the continuous integration feature, which I did want to use in the future. Part of that is I've had a request from the department to pretty much figure that out and put a training manual together for the students and stuff. Aside from that, and I think there's a couple other features that are available. I don't really know all of everything that's available in one or the other.
One more thing, I saw that some of the code put on GitHub needs to be public, or are there like privacy settings that you can switch? Or?
Yeah, so you can have, generally a lot of stuff on there is open source projects. They want people to come in and edit there, but you can give permissions. You can close it only to yourself. You can only allow people who are in your group to make edits to it. There's permissioning there. And you can even have different levels of permissioning, so you can have people who can actually, push directly onto the code. You can have people who can only pull from it and work in their local repo. And if they want to push it to the remote repo, they have to make what's called a pull request. And in that case, then you'd have someone who's allowed to actually work on that remote repo to pull it in. Yep. Cool. Well, thanks for coming. Oh, thank you. Awesome. Thank you so much.
Thank you very much.
Yeah, no worries. Thanks for coming. I hope you learned something.
Yeah.